Hello YouTube, this is Mr. Bakari, and today we are going to look at DeMoivre's theorem. And this is the powers of complex numbers. Okay, so let's get to it. So this formula is DeMoivre's theorem, and what it gives us is a powerful shortcut for raising complex numbers to powers. So we want to remember that any complex number can be written in trig form, which is z equals r cis theta, where r is the distance from the origin on the complex plane and theta is the angle, okay? Remember, cis is just a shorthand for cosine theta plus I sine theta. So instead of multiplying the numbers by themselves repeatedly, like we would have to in standard form, this formula lets us raise it to the nth power by simply raising r to the n and multiplying the angle by n, okay? So we're going to look at a few examples, and you'll see that this is a very powerful tool and a huge time saver. All right, so let's get to it. All right, so up in the left-hand corner here, I've got our formula. And as you can see, we have a complex number written in trig form, and it is raised to the fourth power. Okay, so what we do here is we take r and raise it to n. So n is 4, r is 3. Okay, so 3 to the fourth is 81. We bring down cis, and then we take theta, which is 5 pi over 6, and we multiply it by n, which is 4. So 5 pi over 6 times 4 is 20 pi over 6, which reduces to 10 pi over 3. And that is it. Okay, so just like that, we've got the product of this number raised to the fourth power. Okay, so let's look at another one. Okay, this time we are given a complex number. It's raised to the third power. So we want to find the third power of our complex number. So the first thing we need to do is we need to write this in trig form. So I'm going to come over here to my complex plane, right? Remember, this is our imaginary axis and this is our real axis. So if I just do a really quick plot here, I'll go left 2 and up 2 root 3, right about here. Okay, so I can see I am in the second quadrant, okay? So what I need to do is I need to find r, which is my distance from the origin, and I need to find theta, this angle right here, okay? So I went left 2 and up 2 root 3. I can see that this is a special right triangle. And in fact, my reference angle here is going to be 60 degrees, which makes theta 2 pi over 3. Okay? So theta is 2 pi over 3, and r is going to be the distance to 0 here. And in this case, it will be 4. Okay, you can just use Pythagorean theorem there. All right, so now we have it in trig form, and now we want to cube it. So now we'll go to our formula here. We will take r, raise it to the nth power, so 4 to the third is 64. Write that over here. Cis, and then we're going to take theta and multiply it by n. So 2 pi over 3 times 3 is 2 pi. Now, that is our product, but it says it wants standard form. Okay, so this is something you're going to come across. They're going to ask you to put it back into standard form, your answer. So to do that, I'm just going to expand this, which would be 64 times C stands for cosine theta, cosine of 2 pi, plus I, and then sine theta, so sine of 2 pi. And then I'm just going to distribute 64. Okay. But first, I do have to evaluate these. So cosine at 2 pi is 1, and sine at 2 pi is 0. So now when I distribute 64, I get 64, and then 64 times 0i, which cancels out. So the standard form of this complex number is just 64. Okay? So it ends up being a real number, easier to see in standard form. Okay? So that's how you use DeMoivre's theorem to find the power of complex numbers. I hope this helps you out, and I will see you in the next video.